Hey YouTube, welcome back. Today, our first video, our first video of our series, design consistent hashing, and basically, it will. I guess it will not be a big series. It will be only 3 video series. And first, we will talk about what we need hashing, why we need hashing, and actually what are the problems that are coming from just hashing, and why we need the consistent hashing. So basically, let's just go here and let's just start. Let's just start with the color, this color. So basically, I don't know if you remember, if you watch in the previous video that we talked about the load balancer. Basically, we said that if we have multiple clients, let's say that we have 4 clients and we have 1 minute, and we have 4 servers. Okay, let's just have this, and we want each client to connect to the specific server, and we want to make sure that this client, when it goes to this specific server, it will goes to it each time. So basically, the server will store its cache there actually, and when one of the servers went down, we want something to make sure that it distribute this client requests to different servers. So the way that we try to solve this problem, as we said before, that we are going to use something called a load balancer. Basically, if you don't know what is a load balancer, I highly recommend to watch the videos that I talked about the load balancer in. So basically, we have the client will send the requests to the load balancer like that, and the load balancer will distribute the loads evenly across the servers basically. So we will make sure that we there is no server it's overload, and there is no server is underload basically. So the thing that we have here right now is how is this happening actually, how the load balancer have the ability to distribute the loads actually, and send it to the servers. One of the things that it's using, it's actually the only way that it's using, that we are hashing the clients with keys, and actually send it to get the server indexes. And I will give you tables that it will be easier for us to understand. The thing that they're using the hashing, I guess if you're not familiar with hash tables, you can review also my lead code problems. I have a lot of lead code problems about hash tables. I guess that most of you should be familiar with hash tables, but if you're not familiar with hash tables, I have a video to talk about lead code problems and how hash table works basically. So let's just look at this one. Let's just look at this one. First of all, let me delete this, and let's just, okay. So for this one, we have this table, and if you have basically if you have in cache servers, a common way to balance the load is to use the following hash methods. So if you want to understand what's going on here, because we have key and we have hash, and what is this one basically? So basically, the first client will go to the first server, or like what's going on. So there is a method that we use that it's like the server. Let me type this one with the keyboard. I guess it will be better than the mouse. Server index equals hash, the hash key, the hash key value, and modeled by n. And here basically, here is n is the size of the pool, servers pool. And let me make this wider. Okay, so we have four servers. So we have the key of 0, and we have the first one key, and when we hash the function with this value, we get this specific the index. We get the index of the server that we are going to use. So let's just draw how it will look in the. I guess drawing it will be quite way more easier to understand. So let's just draw this one. Okay, so we said that we have four servers, we have four clients, sorry, and we have first, let's start with the server index, and we said we will have the server, and we will have the keys. So the server index is 0, 1, 2, 3, and the server has like just it has the same like S0, S1, and S2 and S3, S2, and last S3. And let's just look at the hash here. So basically the key is right, key 1, and key 1, key also, what's key, which key key 3, and the next one has key 0, and key 4, and this one has key 2, and key 6, and the last one has key 5 and key 7, and key 7. So what that means, it basically means that for instance, basically the hash of key 0, will equals 1. So the client must a client must connect server 1 to fetch the catch data. So the client 0 should fetch server 1 to fetch the catch data, and it looks quite distributed. The load is balanced, and each server gets has two keys, and each client will have a specific key, and from this key will access a specific server over and over. And this approach basically works well when the size of the server pool is fixed, and the data the distribution is even. So the problem that comes that, however, the problem comes that when the servers are added, or servers are or maybe like existing server maybe like removed, or like fall down, or whatever happened to it. For example, basically if server 1, for example, let's just take this one. For example, if this server went down, this one went down, what will happen right now is the server pool size will be 3. So using the same hash function, basically we will get the same hash value for the key, because it will be the same each time, but it will be modeled on different value, because right now it will not be hash of 4, it will be hash of 3. So we get same. So we will get different server index. So we have above here an example here. So right now it's hash 3, not hash. We modeled the hash by 3, not by 4, because the size of the servers or is changed. So let's just try to draw this again, so we'll understand this. So basically we have the server 1. So basically let's try 0, the server indexes, and 1 and 2, because we only have 3, because the first server has been deleted. And basically we have the server 0 was is 0, I guess. And we said that S1 is removed, so this one will be S2, and this one will be S3. Okay, and let's talk about the hash here that will happen for key 0. For server 0, it will be, we will have to key 0 and key 1 and also key 5 and key 7. And in this one we had key 2 and key 4 and key 6. And in 3 we have key 3 also, because we use the same method here. We use the same method, but we when the size pool it's different, 3 instead of 4, so we get this one. So the problem that we have here is that as you can see right now, most of the key, if you looked at this one, let us try to copy this one and put it next to here. So if you looked at this one, I guess my writing is not good. Basically, my writing is awful. Okay, so let's just look at both of the previous one. 0 has key 0 and key 1 and key 5 and key 7. 0 here has key 1 and key 3. Okay, 1 is deleted. So 2 has key 2 and key 6. 2 has key 2 and key 4 and key 6. 3 has key 3 and key 7. 3 has only key 3. So what we can see right now is that most keys are redistributed, not just ones originally are sorted in the offline server. So basically, we didn't just redistribute the offline server, the keys that have been stored in the offline server. No, actually, we distribute most of the keys. So this means that basically when server 1 goes offline, most the cache clients will connect to the wrong servers, and this will cause a storm of cache misses basically. And to solve this problem, we use something called consistent hashing. The consistent hashing is how we're solving this problem of that when we change the server, when the server go offline, when the server is removed, we make sure that we're only changing the server, the keys of the servers that being removed or being affected, and we're not changing all the other servers. So that's it for today's video, and tomorrow I guess we will talk about the consistent hashing and how the consistent hashing solve this problem. And yeah, that's it for today's video. And if you like this, like my description, give me a subscribe, yes, give me a thumbs up, make sure to hit the notification bell so you will never miss a video. And by the way, I guess I'm saying all the time, like 95% of you are not subscribed to my channel. So if you like, I encourage you to subscribe. So basically our society will be, our community will be bigger and bigger, and this will help us actually in our journey. So that's it for today's video, and see you in future videos.